Well, hello, welcome back. This is Mr. Von Ah, and we are talking algebra. All right, so we've already learned how to solve quadratic equations. Now we're graphing them. All right, so this is going to be the last video on graphing quadratic equations. All right, so this time students will be able to graph quadratic functions of type f of x equals ax squared plus bx plus c. So what's different is right here. So this is standard form, right? And in the past we had it in that form. It was like the x minus h squared plus k. Okay, that's actually better. This form right here, this standard form, we need to actually transform this standard form to that what I call vertex form, which is a times x minus h squared plus k. We need to transform it to that form, okay? Because when it's in this form, we know what the line of symmetry is, and with the k, we know what the vertex is. When it's in this standard form, we don't really know where to start. We don't know how this parabola is shifting, if it's shifting to the left, to the right, if it's shifting up or down. So we're going to be graphing in the dark. Okay, so what I'm going to do is I'm going to show you how to go from the standard form to what I call the vertex form. I'm sure it's not called that, but that's what I call it. All right, so let's take a look, and we're going to look at two examples. All right, so the first example is f of x equals x squared minus 6x plus 4. All right, so the first thing you need to do to get it to vertex form is you need to complete the square. All right, I went over that in a previous video. You can check that out. But in order to complete the square, I need c to be basically half of b squared. All right, so that's how I find the perfect square trinomial. I don't know if you remember that, but to get the proper c, we divide b in half and square it. Okay, so if we take half of b, so half of 6 is 3, and 3 squared is 9. So this really needs to be a 9, okay, but we're going to get there later, all right? So let's go ahead and rewrite this. We're going to go ahead and write it like this. X squared minus 6x. All right. Now I'm going to kind of close this part off. All right. I'm going to keep my 4. I'm going to keep that constant outside. All right. So I know what my c needs to be. What the c for this little binomial, what the c needs to be is what we said, 9. All right, b over 2 squared. 6 divided by 2 squared is 9. So here's what we're going to do. We're going to go ahead and copy everything down. C needs to be 9, so I'm going to add 9 to that. All right? And then I still have that 4 out here, correct? Okay, now this is a perfect square trinomial. Okay, but here's the deal. I added 9. Okay, so when we were doing quadratic equations, we had like a 0 on the other side, right? So we could just add 9 to this side and take 9 away on the other side. Well, this is a function. Okay, this isn't really a number. Okay, so what we're going to need to do is, if we add 9, we can also simply take away 9. So for example, if I give you $9 and then I take $9 away, what's the net result? 0, right? I didn't really add anything to your bank account. That's essentially what we did here is we added 9, and then we subtracted 9. And the net result is we didn't do anything to the equation. We're just moving numbers around. All right, so let's go ahead and factor this, this trinomial. So this is going to be, so if we use our AC method, right, you can check that out on a different video. But when I factor this, it's going to end up being x minus 3 times x minus 3. Okay, I know that because I know that 9 has to, you know, the square root of 9 is 3. Right, and the square root of x squared is just x. So I know this is going to be, the factored form is going to be x minus 3 times x minus 3. Okay, now on this side I get 4 minus 9 is minus 5. Okay? Great. Now I can rewrite this. X minus 3 times x minus 3 can be written as x minus 3 squared minus 5. Now, does that look familiar? Does this form look familiar? Yes, it's that right there, isn't it? It's the vertex form that we were looking for. Okay? So, by the way, I can just feel the questions that you're having. I know that you're asking, how did you get this right here? How did you get x minus 3 times x minus 3? Let me go ahead and do that. This step right here. How did I get from this step to this step? Okay. Well, if I factor this trinomial, let me just try it over here. X squared minus 6x plus 9. How did I get from here to here? Okay, remember the AC method? AC goes here and B goes there. So AC, A times C is just 1 times 9, which is 9, and B is negative 6. So I got to think of two numbers that multiply to give me 9 and add or subtract to give me negative 6. Well, 3 and 3. 3 times 3 is 9. 3 plus 3 is positive 6. So I had to make those negative. Negative 3 times negative 3 is positive 9. Negative 3 plus negative 3 is negative 6. So that's where I got those two negative 3's right there. All right? Just to give you a heads up. All right. So, once I get it into vertex form, I can pretty easily graph this. Okay, so what I do is I set up my little table. All right, 2, 3, 4, 5, 6, 7. All right. Now I got to choose my x values. Question is, what x value do I choose? Well, look at this. I know that my horizontal shift is going to be, well, what number would make this right here equal to 0? Can you think of a number that would make x minus 3 squared 0? Well, x needs to be 3. 3 minus 3 is 0. So I know that I'm going to have a horizontal shift of positive 3. So that means I'm going to put 3 right here. Just stay with purple. All right, that's going to be my line of symmetry at x equals 3. Now I need to choose 3 values less than 3 and 3 values greater than 3. 4, 5, 6. All right? And this right here is my line of symmetry. Okay. So at x equals 0, 0 minus 3 is negative 3. Negative 3 squared is 9. 9 minus 5 is 4. So at x equals 0, f of x equals 4. At x equals 1, 1 minus 3 is negative 2. Negative 2 squared is 4. 4 minus 5 is -1. Go ahead and pause the video right now and see if you can find the rest of these f of x values. All right, did you get your f of x values? All right, let me get mine. 2 minus 1 is 1, 1 minus 5, that'd be -4, and that's -5, and that's -4, -1, and 4. Is that what you got? Hopefully, right? Okay, these are all my x values of my f of x. Now I can plot these points, these ordered pairs, on my coordinate grid system. All right, so 0, 4. 0, 4, so x equals 0, 1, 2, 3, 4, f of x equals 4. 1, -1. Matter of fact, why don't you do this? Pause this video and get yourself a little coordinate grid system and see if you can graph this parabola. All right, 1, -1, right there. 2, -4, 1, 2, 3, 4. 3, -5. 1, 2, 3, 1, 2, 3, 5. 4, -4. 2, 3, 4. Whoop. Right there. Right there. And about there. Huh? So then, oh, my parabola is way off. But let me fix that. That's going to bother a lot of people. Something more like that. A little bit better. I mean, your parabolas don't have to be perfect. Okay, so that kind of confirmed our suspicion. It was our line of symmetry. Our line of symmetry is at x, line of symmetry. So our line of symmetry is at x equals 3, which is what we thought it would be. Our vertex is at, well, it should be at 3. Right? 3 is the horizontal shift, and the vertical shift is -5. So it should be -5. 1, 2, 3, 4, 5. Yes, it's 3 down, 3 over, and 5 down. Okay? So there you have it. That's how you graph. When it's in standard form, you need to first you need to complete the square, get it into what I call a vertex form, and then you're able to make your table, and then you can graph it. Okay, I'm actually going to make another video, and on the next video we will do this example here. This example is a little bit more complicated. Not much, a little bit. There's one little trick that you got to know. Okay, but I'll put that on the next video. All right, until then, may God richly bless you, my friends.